Now we're going to start our unit on differentiation, which is basically just taking the derivative of different functions. In the last unit, we learned how to take the derivative, but we had to use a limit definition, and it was really lengthy. And can you imagine if we had to take derivative of really long polynomials or rationals and use this definition? It would be a nightmare. Luckily, there are easier ways to take the derivative. We're going to show you some differentiation properties and rules that you can use to find the derivative of many different types of functions, and it'll be a lot easier. So let's look at some properties and rules. The first property is that if you take the derivative of any number, it's just going to be 0. So the derivative of 2 is 0. The derivative of 5 is going to be 0, and so on. The second property is if you take the derivative of x, it's going to be 1. Or if you take the derivative of t with respect to t, it's going to be 1. So any variable to the power of 1 will give you that result. The third property is that you can pull out constants. So you can take the derivative of the function and just multiply it by that constant after. It would be the same thing. The fourth property is kind of like your limit properties, that you can separate your limits whenever you have addition, or in this case, you're going to separate your differentiation, your derivatives, through addition or subtraction. Your sixth property is the derivative of e to the x is going to be the same thing, e to the x. And that's just a rule. And then product rule, power rule, and quotient rule are pretty important because you're going to use this time and time again. The power rule is if whenever you have a power and some variable, then to take the derivative of x to the n, you're going to bring down the n to the front like a coefficient, and then subtract 1 from the exponent. For your product rule, you're going to be given two functions multiplied together to form y. So the derivative of y is going to be the derivative of one function times g of x, then the derivative of g of x times f of x. Quotient rule is kind of similar, except that instead of addition, you're going to have subtraction, and then you're going to divide by g of x squared. So for your product rule and quotient rule, they're not going to give you a formula sheet or any of these rules on the AP Calculus exam, so you do need to know them. And hopefully you're just going to use them time and time again enough that it's kind of embedded in your brain anyway. Let's look through some actual examples now. So we're going to use the power rule, that's number 7. So if we want to find the derivative of x to the power of 5, I'm just going to bring this 5 to the front and then subtract 1 from the exponent. That's what the power rule is. So we're going to get 5x to the power of 4. For b, I'm going to change this cube root of x to x to the power of a third. This should be a review from pre-cal. Then we're going to take the derivative of f of x. So I'm going to bring this 1 over 3 to the front using my power rule, and then subtract 1 from the exponent. So 1 over 3 minus 1 is negative 2 over 3. You can leave it like this, or you can change this so that our x to the power of negative 2 over 3 is in the bottom of the denominator. So x to the power of negative 2 over 3 is the same thing saying the cube root of x squared, and that would be under 1. Example 2, we're going to combine our power rule and all the other 6 properties. So by the fourth property, we can split our f prime of x. So I'm just calculating the derivative of this, derivative of the second term, and then the derivative of the third term. So you can look at term by term. I'm going to use the power rule for that first term, which means I'll bring the 3 to the front and then subtract 1 from the exponent. I'm going to bring the 2 to the front, which will multiply with the 4 to get 8. Subtract 1 from the exponent, which is just 1. I'm just going to leave it as that. And then the derivative of 10 is 0. So that's our final answer. For b, I'm going to rewrite this with the denominator as x to the half. And from what we know about rules is that whenever we have the same base and we're dividing, we can subtract the exponents. So I'm going to do x to the power of 2 divided by x to the power of a half. In other words, it'll be x to the power of 2 minus a half, which is x to the power of 3 over 2. 4x divided by x to the power of half is going to be 4x to the power of a half, because that'll be 1 minus a half in the exponent. And then I'm just going to bring this x to the power of a half to the top, so it becomes x to the negative half. Now we can take the derivative of this using the same principles we used in example 2a. So this is going to be 3 over 2x minus 1 from 3 over 2 is a half. I'm going to bring the half to the front, so that's a half times 2, which is 2, minus 1 with the exponent, which is negative a half. Bring this negative 1 over 2 to the front, multiply it by 3, which is negative 3 over 2, and then subtract 1 from the exponent, which is negative 3 over 2. Again, you can simplify this, so it's kind of like this, or you can leave it as is, doesn't matter. Let's just do one more example here before you try it yourself. Again, same sort of principle, just do one term at a time. This the square root of x is the same thing as saying x to the power of a half. You're going to bring the half to the front when you're taking the derivative, and then subtract 1 from the exponent. The 3 is just a coefficient, a constant. We can just leave it there and take the derivative of e to the x. But the derivative of e to the x is still e to the x, so it just stays the same. The derivative of 5 is 0 because that's a constant. So now go ahead and try the next 2 questions, and when you're ready, press play to see the solution. So for the first, try it yourself. You're going to bring this negative 3 over 5 down to multiply with 5, and then subtract 1 from the exponent, and you're going to get negative 8 over 5. Then you'll take the derivative of t, which is just going to be 1. Sorry, this is supposed to be f of t, because everything is with respect to t. And then for e, we're going to bring this root x and multiply with the x and the negative 1, and this is what you're going to get. Bring the 3 over 2 to the front, subtract 1 from the exponent, bring the half to the front, and then subtract the exponent by 1, and then that's what you're going to get. If you want to change everything to radicals, that's going to be your final answer. So now let's look at the product and quotient rule, because we've only really looked at the power rule and the properties so far. So your product rule, I'm just going to write it down, that y prime is equal to f prime of x, g of x, plus g prime of x, f of x. Which means I need an f of x, g of x, and I need the derivatives of each. So I'm going to separate this y into 2 pieces. This can be the f of x, which is the cube root of x, and g of x can be e to the x. Now I want to find the derivative of them separately. And then we'll combine what we have to create y prime. So the derivative of f is going to be 1/3 x to the power of negative 2 over 3 by using our power rule. So the cube root of x is the same thing as saying x to the power of 1/3. We'd bring them 1/3 to the front and subtract 1 from the exponent. The derivative of e to the x is still e to the x. Now we're going to put it all together in this order. F prime of x we found. It's 1/3 x to the power of negative 2 over 3. And g of x is from the original equation, which is e to the x. G prime of x we found, which is e to the x. And then f of x in our y was cube root of x. And that's it. If you wanted to, you can get rid of the brackets and keep it all together. But as you go on, there'll be some really complex looking product rules. And in that case, if I were you, I'd just leave it alone just so that you don't make a mistake while you're simplifying. In B, we're going to use the product rule again because we're multiplying two functions together, and we need to separate the f of x and g of x. So this first bracket here can be f of x. The second bracket here can be g of x. It really doesn't matter which one. We need to find the derivative of each though. So our f of x, the derivative of f of x is going to be 2t by using our power rule. And then g of x is going to be 1 plus 5 is going to be gone because that's 0. If we take the derivative of 1 over t, that's the same thing as saying t to the negative 1. So that means I have to bring a negative 1 to the front. And then minus 1 from negative 1, which is negative 2. Now we'll plug it into our product rule formula. F prime of x we found was 2t. G of x is t plus 5 plus 1 over t plus g prime of x, which was 1 minus t to the negative 2. And then f of x is t squared plus 1. Again, I would leave this as is just so you don't make any algebraic mistakes. You don't need to simplify unless the question states you to simplify, and most of the time I won't unless I need a numerical value out of the derivative. For C, we have a quotient, we have a fraction. In other words, we have a function divided by another function. So I'm going to say the numerator is going to be f of x, and the denominator is going to be g of x. I'm going to write down the formula for the quotient rule, which looks like f prime of x times g of x minus g prime of x times f of x all over g of x squared. So again, we want to find f prime of x and g prime of x. F prime of x is going to be 2t by using our power rule. Then we're going to find our g prime of x, again using our power rule, which is 2t plus 1. And then we're going to plug it into our formula for the quotient rule. So f prime of x was 2t. G of x was given as t squared plus t minus 2 minus g prime of x was what we found, which is 2t plus 1, multiplied by f of x, our numerator, which is t squared minus 1, all over g of x squared. So that's t squared plus t minus 2 all squared. And our last example on the quotient rule, that can be our f of x because that's the numerator, and that can be g of x. We need to find the derivative of each first. If you look at f of x, it's actually not that simple because we have a function times a function, which means we need to use the product rule here to find the derivative of f. Let's let x be our first function and e to the x be our second. So our derivative of x is going to be 1. And then we'll leave e to the x alone, plus leave x alone, then the derivative of e to the x, which is e to the x. In other words, we have e to the x plus x times e to the x. Then for g of x, we're going to use our product rule, our power rule, because we have x to the power of 3. You bring the 3 to the front, minus 1 from the exponent, and then that plus 3 here, when we take the derivative of that, it's going to be 0. So that's our g prime of x. Now I'll put it all together. F prime of x is e to the x plus x e to the x multiplied by g of x, which is x cubed plus 3, minus g prime of x, which is 3x squared, multiplied by f of x, which is x e to the x, divided by g of x squared. So g of x was x cubed plus 3, and then we're going to square that. And then that's all for examples on using the product and quotient rules for now. A lot of these equations are derived with more advanced calculus, so if you actually want to know where these formulas even came from, kind of stay tuned for more calculus.